Function. Graphing a function. Did you have to know this to graph something in grade 8? You didn't. Do you need to know it now? Not really. Kinda. Okay? There's a function. How do we say that? F of x. That's a function f of x. It's a function of x. Before it used to say y. Okay? Think of it as the same thing. That's function notation. That's x and y notation. What's the difference there? One's an f of x, one's a y. All right. The independent variable is the inputs for the 73rd time. That goes on the horizontal axis, like there. Okay? The dependent variable is the output. That goes on the vertical axis, like there. Before it used to be y and x, now it's f of x. Okay? I input some value x. Okay, what's my output? What's f of x? It's just like you're plotting x and y. Okay? Think of it as the same thing. Who has a graphing calculator? Anybody? Okay, quickly. Graphing calculator, guess what? It graphs stuff. Okay? This is a line. You may not know this yet. You soon will. And if you got one of these suckers, hey, there's the line. But we don't need that, do we? We know how to graph a line without a graphing calculator. Use your brain to sketch the graph of this function. How many points do we need, Nicole, to graph a line? You're adding one to what you had last time. No, just 2 points, right? If I give me 1 point, I don't know where this line goes. Does it go like that? Does it go like this? Does it go like that? If I have another point, I know what that line looks like. Guess what 2 points we're going to find out of this guy? If I just have the x and the y-intercept, hey, is this going to be on our quiz in 10 minutes? Okay, I can graph this. Let's find the x-intercept first. What happens at the x-intercept? Say it out loud. Let's pretend we're Chinese. That's how they learn. Everybody repeat after me. At the x-intercept, y is 0. Say it. At the x-intercept, y is 0. Okay? If you yelled that to me in about another 40 decibels louder, it would be like we were in China. That's how they learn. Okay? Y is 0. Uh-oh, there's no y. What do I do? Y is the same as f of x. Okay? Same thing. What is the x-intercept if my output is 0? So we solve this. F of x is my output. Think of that as y. Same thing. Okay? Hopefully we can all solve this. That's a 2-step equation. Get rid of the 1 first, minus it. Whatever you do to one side of the equation, you have to do to the other side. Okay? So negative 1 is 3 times x. How do I get rid of that 3, Emily? Yeah, what's the opposite of times? Divide. Whatever you do to one side, do to the other side. 3 divided by 3 is 1, so it's gone. My x-intercept is minus 1/3. Okay? As a coordinate point, that's my input. That's my output. Remember, y was 0 at the x-intercept. Okay? So minus 1/3. I guess that's right about there. I need one more point, and I can sketch the graph of this thing. Guess which point I'm going to get? I want the y-intercept. What always happens at the y-intercept? X is 0. Always, always, always. Okay? So if x is 0, f of x is, this is the tough part, what's 3 times 0? 0. So if x is 0, if my input is 0, f of x, my output, is 1. Okay? That is the y-intercept. Here it's not a y, it's an f of x. Same thing. Okay? As a coordinate point, that's the point x, y. 0, 1. Okay? 0. There it is right there. So my line must go through those 2 points. Put arrowheads on it, because there's no restrictions here for x, is there? Right? X can be whatever the heck you want. I could let x be 1 billion. Okay? There's going to be some y value eventually way up over there. Does that kind of look like that? Sure does. Okay? If you got one of these, you can always use it to check. I don't teach that, how to use this in this course. Okay? But if you got one, feel free. Okay, looks the same to me. That's how you can graph. Just 2 points, x and y-intercept. All right, that'll be on the quiz. Okay, in each case express the relation. Remember, that's the name of this chapter. Relations and functions. Given in function notation. Is this function notation? Yeah, it says it is, and it is. F of x, that's function notation. Express this as an equation in 2 variables. This is really, really tricky. Okay? You ready? Take a deep breath. Oh my God, that was stressful. Okay, is that now an equation with 2 different variables? X and y? Should that be an easy mark on the test? Okay, all I did was, it was function notation. I made it an equation in 2 variables. Okay, remember f of x, just think of it as y. Okay, did I have to use y? No, all it says is 2 variables. I could have done this, right? I like z's better than y's today. That's okay. Did I answer the question? Yeah. That's an equation with 2 variables, z and x. Okay? G of t. Is that function notation? Yes, it is. I want to write this as an equation with 2 variables. What's your favorite letter today, Emily? E? E for Emily? E is t squared minus 2t plus 35. Is that an equation with 2 different variables? Okay, is that like stupidly easy? No? Yeah, okay. You just got to understand what they're saying. That's all they're saying, okay? All right, now that's an equation with 2 different letters, 2 different variables. I want to write that in function notation. You have any idea how to do this? F of x is 11x minus 15. God, I'm smart, eh? That's function notation, right? Okay. E of x. Could have done that too. G of x, whatever. As long as it's right, okay? You know, that's fine. All right. So I think we get the easy ones. Let's change this question. Okay? Because this one, you just got to play around with a bit more. Okay? By the way, that is general form for a linear equation, but we don't know that yet. I want to write this guy. That's in, okay, I want it in function notation, right? So this one, all I did was, because this one started with a y, let's go back to f of x, okay? That's the one we know. It's not French, that looks like an accent aigu. All right, just change the y to f of x, but here, y is in the middle of our equation. So I have to solve this thing for y first, okay? Then change y for f of x, right? This one's already solved for y, right? It's y equals something, okay? So this one I just got to work with first. Okay, I want y by itself, right? I want y equals everything else, okay? How do I get everything to the other side of the equal sign? Okay, well, let's start with this. Get rid of the 2. Whatever you do to one side, you got to do to the other side. So I got 2x and 3y is 2. Okay? Let's get rid of the 2x. How do I get it to the other side? By subtracting it. Whatever you do to one side, do to the other side. All right? So I got 3y, that's the only thing on the left side now, is 2 minus 2x. Everyone agree? Got one more thing to get rid of. That's the 3. How do I get rid of that 3? Divide it away. Whatever you do to one side, do to the other side, the whole other side. Okay? So y is 2 minus 2x over 3. I'm just going to write this a little differently. Okay, we'll be doing this, so I may as well start now. Is this 2 over this 3? Is this minus 2x also over this 3? I just want to split it apart. Okay? I want to write this like this, because that's the same thing, right? It's just like the opposite of adding fractions. Okay, if I'm going to add a half and 3 over 2, I got to have a common denominator to add or subtract fractions, right? So then I go, well, I got the same common denominator. 1 plus 3, I know it's 4, but I want to write it like that. All I did was kind of go backwards. I started with this thing, and I broke it out into these two, okay? This is the same as this, right? So this is the same as this. I can do that. That's how I want it. I want this number separate from this x term. Okay? So finally, how do I write that in function notation? I just change the y to f of x. Okay? That's it. So that one you got to play around with a bit. They didn't give us an example like that, which is bad for this book. Okay? And they're going to ask you that in some of the assignment questions, so I thought I'd give you one like that. Okay? All right. Graphically, there's a graph. And what else is going to be on our quiz? Domain and range. Before I get there, okay, because we all need review for that stuff, all right? It's tricky. There's a graph. Here's my independent. This is my domain, my x values. Here is my dependent, or my range, or my outputs, right? These are inputs, these are outputs. Doesn't say y, it says f of x. This is a function in terms of x. Think of it just like y. All right? Complete. What is f of 5? See, yesterday we got the equation. We told you x was 5, put it in the equation, find out what the output was. Now we have it on a graph. All we got to do is look. Okay? This says x is 5. If x is 5, what's my output? What's my y value or my f of x value if x is 5? What is this? That's minus 2, right? That's all it's saying. What's the corresponding output if your input is 5? What's f of 5? Negative 2. Okay? What's the ordered pair for this point? You remember this is the first thing we did when we had that graph, that Cartesian coordinate graph named after Descartes. First thing we did, plot points. What's the point here? That's 5 minus 2, isn't it? Okay, let's look at that a sec. That's your input. That's your output. That's x. That's y. Or in this case, that's f of 5. Okay, that's your output. That's f of 5. Sorry, that's 5. That's f of 5. F of 5 is minus 2. Okay? But just think of it as x and y. That's your input. That's your output. If I input 5, this graph says my output is minus 2. Okay? Just a little bit weirder than x and y, but it's exactly the same thing. Let's look at this one. If I input minus 2 on x, where's minus 2? Right here. What's the graph say? For an input of minus 2, my output is 1, 2, 3. Okay? What's f of 4? My input is 4. Again, think of it as x is 4. 1, 2, 3, 4. What's my output? Here's my graph. That corresponding f of x point is minus 1. All right? So as points, that's minus 2 and 3, right? That's 4 and minus 1. Any questions with that? Okay, this says the same thing, only we're going the other way around, right? Just like yesterday. Now, we want to know what x is if we tell you f of x is minus 1. Let me change my color. Okay, my output is minus 1. Or look, there's f of x. That's this. When is this thing minus 1? Right here. Every value there means f of x is minus 1, right? But I just want to look at the value on my graph. Okay? If my output is minus 1, what's my input? Right there. 1, 2, 3, 4. Okay? Now let's go backwards and think about plotting that point. If I said x was 4, 1, 2, 3, 4, what's the point, the output on this graph? Minus 1. Okay, it's just backwards. We're giving you the y-coordinate first and saying find x. Okay? F of x is 3. 1, 2, 3. Here it is. What's different with this one? I got two values. It could be this or it could be that. I got to say both of them. Okay? If my output is 3, well, I could have this point, 2, or I could have minus 1, minus 2. Okay? Both of those give an f of x value of 3. Okay? Lastly, let's use this one. F of x is 4. 1, 2, 3, 4. Here it is. There's the output of 4. Every value on that brown line, f of x is 4. Okay? What's the value of x if output is 4? Could be here, 1, or could be here, minus 1. Okay? The other way, the book would probably write this answer as plus or minus 1, right? That says the same thing. So if you look at your answer and that's what they have, don't get confused, right? That says plus 1 or minus 1. Okay? So use the notation in part A to make a statement about these 2 points, A and B. Point A. What's the coordinates of that point? If we're back in grade 8, all right, I would say that was 5 and 1, right? But I got to use this notation. So how do I write that in this notation? I go f of 5. Oh, yeah, thank you. Negative. I'm going left, negative direction. Got a little dyslexic there. Okay, negative 5 and 1. That's the coordinates of that point, right? So I got to go f of negative 5 equals 1. That says the same thing in function notation. Okay? That's like in this form, in part A. That's what they're saying. B. What color do I use now? How about this? What's the coordinates of that point? 1, 2, 3, 4, 5. Now that's positive 6. And negative 1, negative 2, negative 3. Okay? But I don't want to write it like that. I go f of 6, not comma, equals minus 3. Okay? If I input 6 in this function, this graph, my output is minus 3. There it is. Okay? Inputs, that's x. Outputs, that's f of x. Okay? Yeah, a little confusing. All right. X and Y intercepts. First, well, there's an x-intercept. Here's an x-intercept, right? What's the value of y or f of x here in both cases? 0, right? What's this point? 1, 2, 3. So this x-intercept is 3, 0, and the other one is negative 6 and 0, but I want to write that in function notation. Okay? So I go f of 3 equals 0 and f of negative 6 equals 0. Okay? That's the x-intercepts. The y-intercept, that's right here. There's only one of them. What happens at the y-intercept? X is 0. Always, always, always. It is in this case too, right? How do I get to this point? 0, 5. Okay, so in function notation, I'm going to write that as f of 0 is 5. I input 0, I output 5. Okay, that's all not on the quiz today. But this is. What's domain? X values of this graph. Okay? My X values. Don't even look up and down. Don't look like this. Look this way. The domain of this, and they even threw out down an X here, and the X thing, and the all real numbers, because it's continuous data. All I got to do is what goes here and what goes there. Okay? Let's start with this side. X is, I'm reading this from right to left. X is greater than or equal to what value? That one right there, right? It's all the values greater than or equal to, what's this point? Negative 6. And X, all the X values less than or equal to, well, how far out does it go? It goes out to this point. It's all the points less than or equal to, what's this point? 5, 6, 7. Okay? Every X point you could possibly imagine between negative 6 and 7. That's what this says. Okay? All the fractions, all the decimals, everything. Okay, any questions on that? Range. Now I want to look vertically. I want to look this like that, all right? How high does this graph go? Right there. It's every value under this point all the way down to this one. Okay? In arrows, that's the range. That's the y values of this graph. But I can't write it like that. I have to put it in this form, right? This isn't y now. It's f of x, but it's the same thing. Okay? What's this point? It's everything less than or equal to 5 and greater than or equal to, what's this point? Minus 4. Okay? Where f of x is all real numbers. Okay? Every fraction, every decimal from there all the way down to there. Okay? I said it already, but is this discrete or continuous data? Discrete, is it? It is continuous, yeah. Discrete, remember, would be like just that, and just that, and just that, not all real. Okay? If you join a line, then it's continuous. It's continuous. One more example on continuous and discrete, because some of this stuff I don't know if you've seen yet. If that's time and that's distance, what do you think? Does that make any sense? This is me driving a car. Someone said no. I have to connect it. Why is that? Yeah, good. Okay, so if that's time, I don't know, 1 hour, 2 hours, 3 hours. Yeah, how do I get from 1 hour to 2 hours? This is distance. That's 10 kilometers from my house, 20 kilometers. So I sat there for an hour, and all of a sudden, at that last microsecond, I went beep over to there. I went from 10 to 20 kilometers, right? Yeah, that doesn't happen. Okay? Time is always continuous, because every second, every hour I can break down into half an hour. I can break that into a quarter hour. Okay, every minute I can break down into seconds. Every second I can break into fractions of seconds. Okay, time's always continuous. What if this was speed? I'm graphing my speed versus my time. I'm in my car. I start off at 0. I'm leaving the parking lot. I'm going through the school zone. I'm going to go up to 30. Would that make any sense? How can I just zap from 20 to 30? This is kilometers an hour. Doesn't make any sense, does it? What is the definition? Anybody have this in science yet? You've done some physics? What's the definition of speed? It's distance divided by time. This is your first physics lesson from me. Yeah, change. You're right, change, right? How does this change? And it's the change in the time, right? The more distance you do in a given amount of time, the higher the speed, right? Or the same amount of distance, if you shorten the amount of time you do it in, you're going faster, aren't you? Okay, same thing. This has to do with time also. It's always continuous. Velocity. Yeah. One's a scalar, one's a vector. Speed has no direction, velocity does. What is the definition of the rate of change of speed? That's called acceleration. Is it continuous also, do you think? It's the rate of change. The rates have time in it of speed. Okay? The faster you accelerate, it means you're changing your speed more rapidly, right? Okay? If that makes sense, great. If not, Memorize it. Acceleration is also always continuous. There's time in there. Okay? All right, write this down and then do that after your quiz.